Hi folks! Today we are adding a new board to our list. It is a board from a Philips MC130 /21M/22/30. Is a personal microsystem, and I'm including the extensive reference because there is also one for the MC130 model, but instead of the VFD it has one LCD. The microcontroller is an 87CN71F with code residing on the 40 kilobytes of the ROM and 1.5 kilobytes of the RAM, where the manufacturer has inserted a lot of the code for animation and VFD control. We won't be able to influence the animation dynamics as we cannot change the residing code. However, we will attempt to use the board as a clock, as it has a 32.768 kHz crystal, and its presence indicates that it has the clock function, as this is the value used to the time base for a normal clock. As always, we will need to power our board with the filament voltage, the logic voltage, and the negative voltage. In this case, a value of the less 32.3 volts has used. I would like to highlight the method used to obtain the less 32.3 volts, which consisted of the connecting three DC-DC converters in series, one to plus 3.3 volts, one to plus 5 volts, and one to plus 24 volts. The microcontroller datasheet used the acronym VKK for the negative voltage. The maximum value I found in the datasheet was less 40 volts, but the board layout say less 32 volts. We use less 32.3 volts, but I would like to point out the phosphor glowed above less 12 volts DC. In our list of the videos about panels, we already have a video where the clock can only be set using an infrared remote control. Thirdly, the manual for this board indicated the ability to use buttons to set the clock. However, we encountered difficulties. The clock set button is located on the top of the device near of the CD player cover, a part we don't have. This required pins identification to simulate the panel button on the breadboard, using the pins K2 and P11. No resistance has applied to this circuit as it was already present on the board. To proceed with the association of the converters DC-DC in serial, is necessary to take some cares about the current or the total of the current provided by the circuit. Okay, and I proceed with the measure of the intensity of the negative voltage, and you can see it is near of the 12 milliamperes. The current required by the filament of the VFD is near of the 183 milliamperes. After power up our panel, we stay in front of the three zeros blinking in the VFD. And to proceed with the set of the clock, we need to press the button I implement in the breadboard to emulate the clock set, or the button of the clock set. When I press the button, I change for 4 zeros now, and I have the possibility to adjust or to increase the minutes with it in the button turning plus, decrease the minutes with turning less, and I can increase the hours with preset plus, and decrease the hours with the preset minus. After I press again the clock set, and we have our clock adjusted. If by any reason I press RDS during the process of the set the clock, I receive the message no signal RDS. The format of the hour in this case is adjusted to 24 hours format. Is it possible to perform a test of the panel and also proceed with some kind of the adjusts of the predefined frequency of the tuner? And to go to these steps is necessary press at the same time the button program and the button preset plus. Hold down and after power on the system. We'll receive the message of the software model and we can select after the kind of the test we want. For example, if I want the test of the display, I press the demo and the display is all on. Each time I press the demo, the display is in the next step and so on, okay? We can test the tuner, the quartz test, the tape test, CD play test, and okay, you can read in the manual service how to proceed with the tests, okay? I return to normal stats of the panel, adjust the clock,